Hello students, this is Professor Chalai, and in this video we're going to look at the periodic table. As always, you can follow along using our chapter worksheets. Now, ever since we've discovered that there are different elements and we've assigned them different atomic numbers, people have found that some elements behave very similar to each other. And it formed what we call now the periodic law. Remember, law is just a summary of many observations. So the periodic law states that the properties of the elements are a periodic property, are periodic functions of their atomic number. What does that mean? Well, let's look at the elements and their atomic numbers. Yeah, let's use here. So we have hydrogen, atomic number 1, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen. I'm gonna just skip the video here. Okay, what I've written here are the first 20 elements or so in increasing atomic number. So 1, 2, 3, 4, and so on. So what we found is, for example, as you go down here, you find that helium has a certain set of properties, and then when you hit neon again, it has very similar properties to helium. And as you count down the periodic table, you get to argon. It also has very similar properties to neon. Similarly, lithium has some set of properties. You go down the periodic table, you get to sodium, and you find that sodium has very similar properties to lithium. Again, you get back to potassium, also very similar properties to sodium and lithium. And you could do this over and over again. Beryllium shares similar properties with magnesium, shares similar properties with calcium. Let's do one more with a different color. Fluorine has very similar properties to chlorine. And so we find that these properties are repeating periodically after a certain number of elements. The same properties repeat again. And so what we've done, or what Dmitry Mendeleev has done, is make sure that all of the elements that have similar properties are in the same column in the periodic table. So lithium, sodium, potassium, and all the others are in the same column. Beryllium, magnesium, calcium, and so on are in the same column. And that forms the basis of what we have for the modern periodic table. So let's do those definitions first. A group is the same as a column, and a period is the same as a row in the table. So we'll use these two interchangeably. So the first group here, the first column, we call that the alkali metals. The second group are the alkaline earth metals. The big chunk in the middle here are called the transition metals. These two rows are called the lanthanides and actinides. Over here we have nonmetals towards the left, right, sorry. This group, the second to last group that we have here, are the halogens, and here are our noble gases. Again, I'm not going to write those down because they're all summarized in this nice little table right here, color-coded for you. So that is the organization of our modern periodic table. Some other things that I want to point out that are included in a periodic table: we have the atomic number, we have the atomic symbols, the name, and we also have the atomic mass, the average atomic mass, which comes in very useful and we'll need a lot throughout this course. So those are the 4 bits of information that are included in all major periodic tables. Now, there are a few things that I wanted to point out in the periodic table. The first is metallic character. As you go to the left, it becomes more metallic. As you go to the right, it becomes less metallic. And so if we look at our periodic table, all of these are pretty much metals. Similarly, if you go down, it becomes more metallic. If you go up, it becomes less metallic. And so over here, sort of a diagonal, we got all the non-metals. So these are metals, these are non-metals. And in this nice little, I would say light green region here, we have what we call the metalloids. They have characteristics that are similar to metals and that of nonmetals. So that's it for metallic character. If you go towards the left, it becomes more metallic, right, less metallic, down, more metallic, up, less metallic. Another thing that you could learn from just looking at the periodic table is try to figure out what kinds of ions elements are likely to form. And we'll go over why certain elements form certain ions later on in the semester. But typically, if you're in this first column, you form ions that have charges of +1. The second column or second group forms ions of +2. We're going to skip over the transition metals because those are a little bit more complex. The third column form ions of charge +3. Now, working from the other end, halogens don't form ions at all. They always have 0 charge. Noble gases always have 0 charge. The halogens, which is the second group 7A, if you will, always form ions of charge -1. The third column from the right forms ions of charge -2, and so on. So just by looking at where they are in the periodic tables, we can try to figure out what sort of ions, charges the ions that they form would have. With that, try to go over this number 10 as an exercise and try to figure out what ions each of these elements would form if they do form ions. And pause the video, try to do them, and then we'll go through and figure some out together. Okay, so by looking at the position of aluminum on the periodic table, aluminum is in group 3A right here. We can learn that if aluminum forms an ion, it will likely form a 3+ ion. Let's do another one. Let's do fluorine. Fluorine is a halogen, right? So it's found in group 7A right here. It's right there. So it's likely to form an ion with a -1 charge. So fluorine would form an ion of a -1 charge. Usually we ignore the 1 and just put a minus sign. Magnesium. That's a nice element. Magnesium is an alkaline earth metal. It's found in the second group right here. And so it's likely to form an ion with a charge of +2. There we go. Sulfur, right? Sulfur is right here, right below oxygen on the periodic table. Likely to form an ion with a -2 charge. So sulfur, 2-. If you have questions about any of these, let me know. But to summarize, in the periodic table, more towards the left you go, you become more metallic, versus towards the right, you become less metallic. Towards the bottom are more metallic, towards the top is less metallic. And then just by looking in which group or element is, we can figure out what sort of ion it will form. Now, I mentioned that these properties are repeating, and that's the periodic law. And so to make things simple for us to understand, Dmitry Mendeleev created this table where all the repeating elements, the repeating properties, are in the same column. Now, there are multiple ways that we can go about actually designing a periodic table such that it makes sense. This is just one way where we put it into rows and columns and make sure all the ones that are repeating are in the same column. But people have come up with very different strategies. For example, take a look at this periodic table right here. We can see that, for example, all the noble gases are in the same sort of region. If you can follow my mouse right here. The alkali metals are in the same region. And so they also give the same information as a regular periodic table, right? They group similar elements that have similar properties together. For example, this region here are the transition metals. Over here are lanthanides and actinides, and so on and so forth. Or maybe let's look at this periodic table where these numbers will make sense a little bit throughout the later in the semester. But again, similarly, we have our noble gases in this row. Then we have our alkali metals, and so on and so forth. So every row in this setup are elements that behave very similarly. And up here we have our lanthanides and actinides. And how about this one right here? Every spoke on the wheel is now is the same period. For example, where are noble gases? Our noble gases are right here: helium, neon, argon, krypton, and so on. Here are alkali metals: hydrogen, lithium, sodium, potassium. Here are alkaline earth metals. This whole region have a bunch of transition metals, but they keep the same periodic structure. The way that we lay out our periodic table really is a matter of choice. The standard form that we have right now is just the one that is everyone's most familiar with, and it's the one that we're going to stick to. I will see you in the next video where we talk more about molecular and ionic compounds.